Hey, I want to welcome you all back. I know this isn't how we plan on starting the year, but this is what it is. So let's try and make the best of it. So I want to welcome you to the AP Physics 2 course. I want to spend a little bit of time today introing you to what we're going to be doing in here and also reviewing some stuff from last year that you're going to need to be able to use again this year. So let's start things out. Really excited about a lot of the things I'm going to get to teach you guys this year. You'll be learning things like quantum physics, nuclear physics. We'll be talking time travel, black holes, all kinds of stuff that's going to blow your mind. I'm going to try and save that for when we're back in person. So I'm not going to start the year like I normally would with nuclear physics. We're going to save that until hopefully we at least have hybrid or even full learning. But we will get to it, and I promise you will really enjoy learning about it. We also are going to be learning about a lot of things on how they work. I think you'll find them pretty fascinating. Things like car engines, air conditionings, airplanes, all kinds of really neat things, generators, alternators. I think you're really going to enjoy the content of this course. I want to let you know what your daily schedule is going to look like. So I want to let you know that I'm going to post all your work ahead of time. So for those of you who work better later at night, early in the morning, whatever, I'm going to try and be flexible in the sense that I will post your work early so that if you want to, you can get most of it done before time. All your major notes will occur via pre-recorded videos like the one I'm doing now. My justification for that is that if I pre-record it, I can make sure it's as perfect as possible. And if there are any issues with your internet connection or any issues that keep you from being focused during the class time, you can watch the video at your leisure. All daily assignments will be due at 4 p.m. of that school day. So again, they'll be posted ahead of time if you want to get them done early. But they must be done by 4 p.m. of the school day where we work on them. Okay, you must log in during the class period to check in, to ask questions, or just say hello. So I'm never going to keep you for the entire class period on a live Google Meet. But I do need you every single day to log in at the beginning, just say hello, let me know if you have questions, and then go about your day, finishing up whatever assignments we have for that day and making sure they're ready by 4 p.m. You must ask your questions of me during our class time. The rest of the day, I'm going to be with other classes or preparing or grading from previous lessons. Okay, so our class time is your chance to ask me questions, and if you don't have any, you can log out of the meet and get about your daily work. Make sure it's done on time. Okay, I want to let you know how you'll be graded. So there'll be some kind of graded assignment almost every single day. The assignments will be worth 10 points, every single one, no more, no less. You'll be given a professionalism grade each week. The professionalism grade will be based on your daily attendance. Did you show up? Did you show up on time? Did you ask questions when you needed to? Did you verbally check in with me each day? And did you have things done on time? You are having a very unique opportunity to learn how to self-manage your time. We're going to grade you on whether or not you're able to do this well. This is a very important skill to have in our modern society, showing that you can self-discipline and get things done when you're supposed to. Okay, so the first thing we're going to do is we want to review the idea of forces and make sure you know how to use the forces that you've already learned about. Now, forces are going to be something that we're going to be studying in detail this year also, because literally forces might be the most important thing in our whole universe. What are they? Well, hopefully you remember that forces are pushes or pulls on an object. Okay, so whenever we pull on an object, whenever we push on an object, we are creating a force. Remember that forces are measured in newtons, And for some people, they still use the older standard of pounds. But in science, forces are newtons. Okay, so why are they important? Because literally without forces, nothing could ever change. So objects that were at rest would stay at rest forever. Objects that were moving would continue to move in a straight line forever. So forces are agents of change. Forces allow changes to take place. Some examples of forces, hopefully remember things like gravity, like elastic, like friction, and things like that. We'll talk about each of them in a little bit of detail in just a moment. But I also want you to remember the big idea. Forces cause acceleration. If you have an object traveling along and you apply a force in the direction it was already moving, it speeds up. If the force is against the direction it was traveling, it slows down. And if it's perpendicular, it changes direction. Forces cause change. They could speed you up, slow you down, change your direction. Without a force, you can't speed up, you can't slow down, you can't change direction, you can't do anything. How much acceleration is there? Well, that depends on how strong the force is. A stronger force makes a greater acceleration. You speed up quicker, you slow down quicker, or you change direction more rapidly. The main forces we learned last year, gravity. Anytime we have two objects, there is a gravitational force pulling them together. This is an extremely weak force. In order for gravity to be noticed, you need to have at least one object that is massive, or in this case, two objects that are massive. And the gravity is determined by the masses multiplied together times the gravitational constant divided by the distance between their centers squared. So we learned this, we used this last year. Just remember this formula and be able to use it when necessary. Remember, if you're on Earth and you're close to sea level, Franklinville's close enough to sea level, gets a little bit closer every year. Okay, and gravity at sea level, force gravity equals the mass of the object times the gravitational field strength. For Earth, I hope you remember that's 9.8. 9.8 newtons for every kilogram of mass. So this guy is 1 kilogram. He would have a force gravity of 9.8. This guy's 2 kilograms. He would have a force gravity of 19.6. Force electric is just like force gravity. Instead of masses, it's based on charge. Remember, electricity can attract or repel. And remember, electricity is much stronger. We use Coulomb's constant instead of the gravitational constant. We have friction and normal when we have like a box sliding across the table. Remember, normal means perpendicular. So you have your force, gravity, pulling down. You have your force normal, pushing up. And if the box was moving in this direction, you would have friction trying to stop it. Friction is found by using the coefficient between the two surfaces times the force normal. Okay, we have the force tension. When you have a rope or a string, or in this case a lanyard, there's a force tension holding the object up. There is no formula for force tension. You have to figure it out case by case. But you'd have gravity and you'd have tension. Then we have force elastic. The difference with elastic is it's something like a rope, but stretchy, like a bungee cord. And you can find the force elastic by taking the spring constant and multiplying by the amount of stretch. So again, these are the forces that we learned about last year. and then we learned how to get net force. Net is the most important because that means total. So if you have 4 forces pulling on an object, you would take all the forces to the right, add them up, take all the forces going to the left, add them up, then you would subtract. If the forces to the right are bigger, the net force is to the right. In this case, left is bigger, so you would take this number minus this number, and that would get you your net force. So all I'd like you to do today is complete the slide presentation that I have attached to your assignment for today, showing me that you remember how to do a few of these skills. Again, if you have questions, feel free to ask during our class time. This assignment will be due at 4 p.m. Thank you.